This is problem 21 of chapter 14 from the textbook Stats Modeling the World by the authors BVD. Okay, so this problem here is it's about polling, and what happens is that when we call homes, a couple things take place. So the first thing that takes place is that first thing that takes place is that we either contact them or we don't contact. So let's just call this contact. Or fail to contact. Okay, so if we contact them, something else can happen. Either they accept, sorry, having trouble with this, they accept, or they refuse. Okay, so this tree concept is actually part of chapter 15, but it works here. So they're saying that it's the probability of contacting somebody is 0.76. So 1 minus 0.76 would be 0.24. And the probability that they'll accept is 0.38. When 1 minus 0.38 is 0.62. Okay, so if our model should be intact, but to verify it, we would have 0.76 times 0.38, and here we'd have 0.76 times 0.62, and then here we just have 0.24. So if we added these all up, we should get 1.00. So let's just check just to make sure our model's correct. So 0.76 times 0.38 plus 0.76 times 0.62 plus 0.24. So it's 1. Okay, so we have a good representation of the problem. Now let's look at the first question. What's the probability that the next household will be contacted but refuse to cooperate? Okay, so that's the probability. We would write that probability of contact and refuse. Okay, so that's going to be equal to the probability of contact times the probability that we refuse. Okay, so that essentially is this branch right here, 0.76 times 0.62. So 0.76 times 0.62, and let's just see, clear, 0.76 times 0.62, that is 0.4712, so 0.4712, or 47.1% of the time. Okay, so that's how you do that problem. The tree helps me kind of navigate. Now this question on B is a lot more difficult, I think. What's the probability of failing to contact a household or of contacting the household but not getting them to agree? So basically failing both ways. We either fail to contact or we contact them but they refuse. Okay, so if we modeled that, that would be the probability that we contact or fail to contact or we contact and they refuse. Okay, so now if we kind of think about this, there's a or, so we're going to add. So the probability of that we fail to contact plus the probability that we contact and they refuse. Okay, well, we've already done this part up above. So this is, let me just write it one more time. So my logic is readable. Probability that we contact times the probability of refuse. Okay, so now we just plug and play. Failed to contact, that was 0.24. So we have 0.24 plus 0.76 times 0.62. So let's just see, clear. 0.24 plus 0.76 times 0.62 equals 0.7112. So 0.7112, or if you like percents, 71.1% of the time. Okay, last question. How can you do this calculation here another way? Well, the only thing I can think of is if we go back to the tree, we were interested in, we were asked to find this path, okay, this path right here, and refuse, and this path. Okay, so basically you can kind of see 0.76 and 0.62 and a 0.24, so we added these. So what we could do is we could find this branch. We could find this branch right here, which is, and subtract it from 1. And that would give us the same thing. Okay, it's called the complement. Let's see if I can get back to the color black. Okay, so rather than writing this, let me just say I'm going to cheat because I don't want to waste too much time, but you'd write that out and it'd be 1 minus the probability that we contact and they accept. Right? They contact and they accept. So that's 0.76 times 0.38. So 1 minus 0.76 times 0.38. And if we go to a calculator, clear, 1 minus 0.76 times 0.38, we get the same thing. Okay, so 0.7112 or 71.1%. Okay, so this is called the complement, and it's easier to see it, I believe, when you work with a tree. Anyway, that's problem 14. Problem 21, chapter 14. Good luck.